Hello students, today we are going to discuss about the zeros of a polynomial and the relationship of the zeros and the coefficients of the polynomial. That is exercise 2.2, and first question is polynomial is x square minus 2x minus 8. First of all, we shall factorize this polynomial. This is quadratic polynomial and it will give us two factors, x square minus 4x by splitting the middle term, that is minus 4x plus 2x, minus plus minus 4 minus 2, 2, 4 2s are 8, and taking x common from first two terms, x minus 4 is here and 2, x minus 4 again, x plus 2, x minus 4. These are the factors. Now px will be 0 if these two factors x plus 2 is equal to 0 or x minus 4 is equal to 0, and it will give us x is equal to minus 2 or x is equal to minus 4. So two zeros will be minus 2 and plus 4. Further, for verification, sum of zeros is equal to minus 2 plus 4. It will be plus 2, and if you note, it is minus coefficient of x over coefficient of x square. You can check what is the coefficient of x square, that is 1. Coefficient of x square is 1 and coefficient of x is minus 2, and if we divide we will get 2, that is same that of the number. And product of zeros, minus 2 into 4, that is 8, and what is it? It is a constant term with negative sign, and you can write constant over coefficient of x square. This is true, therefore verified. Next question, question number 2 is PS is equal to 4s square minus 4s plus 1. Again we shall factorize it. 4s square, we shall split the middle term in two terms whose multiplication will be 4. 4 ones are 4. We need 4 for multiply, and it has two possibilities. 4 ones are 4, 2 twos are 4, and we need this pair to make this term 4, that is 2s minus 2s plus 1, because 4 minus 1 will make 3 and 4 plus 1 will make 5. So we shall use this pair of numbers to make it 4 completely. Now taking 2s common from these, s minus 1 minus 1, 2s minus 1, and 2s minus 1 into 2s minus 1. These are the factors. Therefore ps is equal to 0 if 2s minus 1 is equal to 0, or second factor 2s minus 1 is equal to 0. 2s is equal to 1, s is equal to 1 by 2, or 2s is equal to 1, or s is equal to 1 by 2. These are the same. Now we come to verification. Sum of zeros that will be 1 by 2 plus 1 by 2 equal to 2. That will be 1. And what is it? It is minus coefficient of s over coefficient of s square. It is true because coefficient of s is minus 4 and s square is 4, and if we write minus coefficient of s over coefficient of s square, it will also make 1. So 1 can be written as this. And product of zeros, one by 2 into 1 by 2, 1 by 4, and you can see it is constant over coefficient of s square. As constant is what? Constant is 1 and coefficient of s square is 4, and 1 by 4 is written in the form of this. It is verified. Question number 3. That is px is equal to 6x square minus 3 minus 7x. First of all, write in a proper sequence 6x square minus 7x minus 3. Now factorize it. Now we need 6 3s are 18. What are the pairs of 18? In the form of multiplication of two numbers. 18 1s are 18, 9 2s are 18, 6 3s are 18. Now we need 7 and this pair will be used. 6x square minus 9x plus 2x minus 3, and 3 is a common between this. 2x minus 3 plus 1, again 2x minus 3, and factors are 3x plus 1, 2x minus 3. Therefore this polynomial will be 0 if 3x plus 1 is equal to 0, or 2x minus 3 is equal to 0. 3x is equal to minus 1, x is equal to minus 1 by 3, or 2x is equal to 3, x is equal to 3 by 2. So these are the zeros of this polynomial. Further verification. Sum of zeros is equal to minus 1 by 3 plus 3 by 2, and by simplifying we shall get 6 as LCM. 3 2s are 6, 2 1s are 2, 2 3s are 6, 3 3s are 9, 7 by 6. And what you see, it is coefficient of x and it is the coefficient of x square. So it can be written as minus coefficient of x over coefficient of x square, and product of zeros minus 1 by 3, 3 by 2, and these will be cancelled. Minus 1 by 2 is here, and minus 1 by 2 is what? If we see constant term, that is minus 3 over coefficient of, if we see constant term minus 3 over coefficient of x square, that is 6, we will get 1 by 2 with the negative sign, that is here, and it can be written as constant over coefficient of x square. Verified. Next question, question number 4, that is PU is equal to 4u square plus 8u. As it is a quadratic polynomial but it has no constant term, so it can be factorized easily by taking out common variables and numbers, that is 4 and u are common, so here we shall get u and 2. So P u will be 0 if these are the two factors of this polynomial. 4u is equal to 0 or u plus 2 is equal to 0. U is equal to 0 by 4 or u is equal to minus 2 or u is equal to 0 or u is equal to minus 2. These are the zeros of polynomial. Now come to verification. Sum of zeros, that will be 0 plus minus 2. It will be minus 2, and it can be written as coefficient of u with a negative sign over coefficient of u square minus coefficient of u over coefficient of u square, because coefficient of u is 8 and coefficient of u square is 4 minus, and it will be minus 2, that is minus 2 is same, and product of zeros is equal to 0 into minus 2, that will be 0, and we know that our constant term is 0, or we can also write it as 4u square plus 8u plus 0. So 0 is a constant term, so it will be constant over coefficient of u square. So it is also verified. Next question is Question number 5th, that is pt is equal to t square minus 15. It is also quadratic polynomial, but it has no middle term or the term containing t. It can be factorized in different ways. We shall use this formula to factorize this polynomial, that is a square minus b square is equal to a minus b, a plus b. First of all, we shall convert this polynomial into this form, that is t square minus 15 can be written as under root 15 square. Now you can see these forms are same. Here a is t and b is under root 15. So by using this formula we can make the factors t minus under root 15, t plus under root 15. So these are the factors of this polynomial. Now for zeros, therefore pt is equal to 0 if t minus under root 15 is equal to 0, or t plus under root 15 is equal to 0. That is t is equal to under root 15 or t is equal to minus 15. So these are the zeros of this polynomial. Now verification, it is sum of zeros is equal to under root 15 plus minus under root 15, that is under root 15 minus under root 15, that is 0. Now it can be written as t square plus 0 into t minus 15, because we have not the term that is containing t and we shall take the coefficient 0 of that term. These polynomials are of same order and are of same value. So it is the 0 and 0 is what? It is the coefficient of t minus coefficient of t over coefficient of t square, and product of zeros is equal to 15 under root into minus under root 15, that is minus 15, and 15 is what? That is constant term. Constant over coefficient of t square, hence verified. Last question of question first is 6th px is equal to 3x square minus x minus 4. Now to make factors we need 3 4s are 12, and 12 can be written in many ways. 12 1s are 12, 6 2s are 12, 4 3s are 12, and we need 1 here, and 1 can be obtained from this pair. 4 minus 3 is 1. So 3x square minus 4x plus 3x minus 4, and x is taken common from these two terms. 3x minus 4 plus 1, 3x minus 4, and the factors will be x plus 1 and 3x minus 4. Therefore px is equal to 0 if these two factors will be 0. This is equal to 0, or 3x minus 4 is equal to 0, x is equal to minus 1, or 3x is equal to 4, x is equal to minus 1, or x is equal to 4 by 3. 3 is divided to 4. Now come to verification. Verification. Sum of zeros is equal to minus 1 plus 4 by 3, and 3 will be the LCM, and here we get 3 plus 4, 1 by 3, and it can be written as minus coefficient of x over coefficient of x square, and product of zeros, minus 1 into 4 by 3, that will be minus 4 by 3, and it is equal to constant term over coefficient of x square. Hence verified. Hope you all students have understood the question first, that was related to zeros of polynomial and the verification of the relation between zeros and coefficients. Thank you.